Watershed Analysis. In this video, we'll be focusing in our final preparation process where we're extracting data. Now we have a DEM that covers a very, very large area, and we want to focus in on this area of interest, this small area of interest. So what we're going to do is use our toolbox to spatial analyst tools, extract by mask, to pull the information out just for that small area of interest. Our input raster would be our DEM, and our feature mask data would be our area of interest, and within our geodatabase we would call it study DEM 01. We extract that data. When it's done, we see the green checkbox in the bottom that our work has been completed successfully, and we can see now that our DEM has been extracted to our area of interest. Our next step is to actually use the fill command to fill the pits or local depressions along which a stream would be expected to flow. Now, our process uses our toolbox and our hydrology function where we're doing the fill command. We select our study DEM as our input raster, and we direct the output to fill study DEM in our geodatabase, and we leave our limit, our Z limit, empty. And I'll talk more about that in a second. Now the fill command is a process where it takes the DEM and it looks for small little areas where the water would pond up, or dead ends or pits, and it goes about filling those pits or dead ends that would trap the water. Now what we want to do is take a look at that when it's completed, and you'll notice that the fill DEM is very similar appearing to our study DEM, and it's got some of the dead ends or pits filled in, and we'll need to understand how much. So we'll use our toolbox, and we'll use the map, the minus command, to subtract from our study DEM the fill DEM, and we'll use a name of difference. And we'll select OK. Now what this will show us is those areas that were filled in. Now we'll want to turn off our DEM, and we'll want to change the color in the difference layer using symbology to show the displayed values, background values, as no color. And we apply that, and this actually helps us see the areas that were filled in through the fill command. Now I'm zooming in, and you'll notice that there's several areas where the water was ponding up on the surface, and that it had to fill into those pits before it spilled out to move across the landscape. And you'll notice that this fill command filled from to a level of 85 centimeters. And you can see that there's one area here and another area here where there actually was a good bit of filling going on, about 3/4 of a meter or so. Now this filling process is something that needs to be done quite carefully. It's quite easy to do the fill and just fill all the pits, but that is often not the correct approach. You really need to fill the pits in, and then examine what the difference is and determine whether this is something which you want to accept or you want to change your Z parameters. Now you'll notice the speckles all across the landscape. Those are errors or tiny little pits, and that we clearly want to fill those in. And in this case, this is a fairly small filling that we're doing in this landscape, about 85 centimeters, and that for our analysis we're going to just accept all of these fill recommendations from ArcGIS, because we want to understand how water is moving across the landscape. But you do need to be aware that there is a little bit of a pond here and a little ponding area here that where the water will collect to a certain level, and then it needs to spill out after it reaches some number of centimeters. Our final step is to remove the difference, because we don't need that for our later analysis, and to remove our larger DEM just for space purposes. So we have our fill DEM for our subject area, and our area of interest, our imagery, and our study DEM, and our outlet layer. This completes this video.